Hello everyone, and let's continue exploring the text-to-SQL project using LLMs. Now this is an ongoing series, so I encourage you to watch the previous videos in this playlist to completely understand where we are heading towards. Also, a quick note before we dive into the video. At the time of recording this video, I started a YouTube channel, and earlier I posted my videos on this project as well as around Langsmith and some prompting techniques on LinkedIn and on Twitter. But now I moved it to YouTube, um, and then in the last a week or so, and I gained maximum engagement for the Text-to-SQL project. And I in fact had stopped working on this project for a few weeks now, but it encouraged me now to come back to this and continue working on it. So yeah, if you're new here, I'm Vijay and welcome to my YouTube channel. I make videos around AI and LLMs. So if this is something that interests you, then do consider subscribing and following my content. With that, let's dive into today's video. So in the previous video, we had built the version v5 of the model of this app. In this video, we might not or we won't necessarily be building a new variant or like a new version, but what I thought was maybe we can take a step back and try and identify areas where we can improvise this. All these red arrows are the kind of areas where I identify we could improvise and build upon. Now the idea for this is that see, over the last few videos we iterated through the variant v1 to variant v5, right? Sorry, version v5. And now this is fine, but when you see it from a production point or in a true sense, right, this is probably the version v0, because this is like a baseline model that's good enough to answer I don't know, SQL questions that are easy to intermediate. It is able to have these additional context in between, able to handle some complex questions also. So in true sense, this is probably like the version v0 in my opinion. Now when you want to optimize this for your specific business use case, is when you have to identify areas and work upon them. Now again, in a production environment, or like in a business use case, you might have limitations, or you will have areas that you might want to specifically focus upon, business, depending on the use case. But given this is like a project, we have that sort of liberty to work and expand upon in ways that we want on our own. I think we might end up over engineering few aspects, but I think it gives us a good practice to see the whole big picture, see what are the areas that the model can benefit in terms of upgrading in the whole sense, but also focusing on specific areas that can be a good practice. So with that, let's go in detail. So starting with the user and the user query, right? One of the things that we should focus on is to optimize the user query. Right, what I mean is, the user query can have some typos, or it might not make complete sense, right? So we should ideally have a node in between that can look at the user query and self-optimize it. So it can look for some common typos and optimize those, and it can also maybe reach back to the user and ask for additional context if it feels that maybe some information was not accurately provided, or if the question was like, incomplete. And this thing is called human in the loop, right? So user provides an input, but also stays present throughout the loop. We can try and do something like that in between. The second would be to build guardrails for SQL injection. SQL injection means that the user can feed in malicious input or malicious SQL code that can impact the database. Now, of course, in our current version, we haven't connected it to the database. We are simply generating a SQL code. But in future, if we connect it to the database, then we don't want the user to know or no have an dangerous impact on the database. Also, even in terms of SQL generation, right? We don't want the user to gain access to unauthorized data. Um, or say we have these knowledge base, right? We don't want the user to gain access to these knowledge base that is confidential. So again, build a sort of guardrails for SQL injection. And the third step is to build a database for repeated questions. This is something that I'll come back to in some time, but I think these are mainly the three areas that we can focus on with in terms of the user and the user queries that's provided. Now, moving on to the knowledge base, I think this is where we should focus on mainly. So the current workflow takes in the sub questions, and it takes in the knowledge base. So this knowledge base consists of all the tables, table descriptions, column and column descriptions, right? Now, based on this, we identify the specific tables that is needed to answer each sub question. Perfect, right? And also based on these tables that's mapped, we are selecting the specific tables, going back to the knowledge base and filtering it so that we have only the specific knowledge base. And this knowledge base or the filtered knowledge base is what is passed on in the subsequent steps. So the main chain of thought at the point of building this version was that we don't want to pass the full knowledge base in subsequent steps, because that would involve passing on a lot of tokens. And that was a good initial step in my opinion. But this step, like the first step, right, where we provide the knowledge base, that itself consists of all the tables and the column descriptions. So this step in itself is like heavily is like token heavy, right? And now it is fine for our use case, but if you look at production grades where you have hundreds or tens and hundreds of tables, you just cannot pass on the whole schema into the node, right? It would surpass the what do you call the context window, and you probably won't even get the SQL generated for a very basic question. So you don't want to run into limits here. So what we can ideally do is, instead of bringing in an LLM, maybe we can do some sort of filtering on the knowledge base using semantic search, right? So we can embed these sub questions and do a semantic search between the sub questions and the knowledge base, so that way we can identify basically the same, right? We are identifying the tables, but not necessarily using the LLM here. Instead, we'll have like a separate workflow that feeds in the knowledge, filtered knowledge base right here itself. So some sort of semantic search can be explored, or we could also do metadata filtering, right? So now we okay, let's take the example of this our database. Now if you look here, we have certain tables that's called orders. We have some called the products, some related to sellers, some related to customers and geolocation. So I think broadly we can group them into few categories, right? Orders could be one, products could be one, sellers, customers, and so on. So I think these kind of data or metadata can be attached to the knowledge base, and we can filter them upon that. So if the user question consists of any keyword that includes orders, we can filter all the orders table, or we can filter and look specifically into that, right? So some sort of metadata filtering. And the third would be user input. So If you go back to the first variant, right? Here we fed in the tables and column, the basically the schema right into the query, and effectively this was the least token heavy variant that we built, because here the user knew what tables had to be provided, and he provided the entire schema. Um, Now, what if the user that we're talking about knows which columns to explore? We don't necessarily want to have this particular step, right? We can directly go from user to filtering on the knowledge base. So, depending on the user sort of knowledge, maybe we can also take in the user's input. So, maybe instead of along with the user query, we can have an additional field that also takes in any tables that the user might think is necessary, right? So user query is mandatory, the tables can be optional. So if the user provides tables, the step can be ignored, or if it doesn't, then we go through the traditional way as we built. So of course this is something that we can build, and this can heavily boost our sort of the knowledge base that we build. It can reduce the token usage, it can reduce our latency time and so on. So this is something that we have to try and optimize. It involves RAG, right? Because you are effectively retrieving the knowledge base, or retrieving the relevant information from the knowledge base. Of course, this involves at least personally for me to explore different RAG workflows. So I'll come to this optimizing knowledge base at some point, but nonetheless, it's an important one. And second thing to optimize here is to account for new tables and columns. Now, our current script um, involves, if you go here, right? Let me pull this up quickly. So here we have the knowledge base builder. Of course, we looked into these steps. It takes in few examples and builds. It takes in few examples and builds your knowledge base, um, which was this one. So it takes the examples from the database itself, right? I think I forgot that. Yeah, so it connects to the MySQL, like your database, and then picks up certain columns and certain values within the columns, and then builds this knowledge base. Now, sure, this is fine, but what if it's a growing organization and you have new tables or new columns within the table? Maybe certain column names have changed and so on. You can run the whole script, but uh, it is going to be computationally heavy, in the sense you don't want to rebuild on the same knowledge base again and again, right? You just want to add the new tables or columns that's been added, and this sort of script can be automated to run every week, once every week or once every month, so that the knowledge base is up to date. um, and speaking of knowledge base, if we move towards the sort of embedding model, then whatever knowledge base is built has to also be embedded. So these are the downstream tasks, right? When we have new tables or columns, so that is something that we have to account here. And thirdly, we also have to aim to capture business knowledge. Now, of course, here we don't have much business context here, but nonetheless, this is something we should try and explore. And what I mean by business knowledge is, right, sometimes some columns, even based on descriptions, might not evidently capture the underlying business context, right? I could say identify the successful orders um, in this department, right? Or identify the successful orders. Now, how do I identify successful orders? Maybe there's no column that explicitly says the order was successful, right? If at all there was a flag or column that says, hey, this order was successful, this is in pending, this is in progress, and so on, the LLM will know that it has to filter upon the specific column. But what if there was no specific field as such? Maybe the underlying business knowledge is that if there is a delivery date, it means the order was successful. Now, this is something that the LLM might not inherently capture. So these are some additional business knowledge that we have to also incorporate within our knowledge base. Now, I don't know what kind of knowledge, business knowledge we can incorporate within our data set, but surely we'll revisit this at some point to make our knowledge base robust. Moving on, so we have four LLMs here, right? Four nodes, so four LLMs. And currently we are using OpenAI's models for all of them. I think I've used 4.1. Can't remember, but yeah, we have used a single LLM for all these four, and it is good. It's a state of the art LLM, and it'll perfectly do its job. But the thing is, these LLMs come at a cost, right? We are using the API, so there is token usage and the associated API cost. Now, when you go to a production grade for your business, also you might not necessarily want these data to be passed on to a third party like OpenAI. Maybe you probably want to have more control on the kind of data you're feeding into these LLMs. So what we want to do is to maybe use some open source models that you can run locally, or even if it's like a third party LLM, maybe you want to use some lightweight models. Not all models require a state of the art OpenAI's 4.1 model, right? You could go with some lightweight models that can be less heavy, and also cost you minimally. And a second aspect to using different LLMs is also that you can make use of these strengths of different models. Now, sure, one could be great at SQL generation, one could be great at some sort of reasoning. So you want to explore the strengths of different LLMs and specifically use them in the workflow. I'm sure there are models that's just great at or was sort of modeled to generate SQL. So I can probably just use that instead of using some optimized models, right? So that is one area we should explore. And second is error handling. At the moment, I can't remember, but I think there's very minimal error handling in my code. If this model fails to give the output in the right context, the model just breaks or stops in between. But we should handle it efficiently and maybe output relevant information to the user, right? One more, error handling is also associated with the LLMs themselves. If a certain LLM fails to run, or the API has some issues in between, we should fall back to another LLM. Now, the problem associated with that is that it also comes with maybe varied prompts, and the kind of data that it understands and passes on, right? If all my queries are now optimized for a certain LLM or certain model, right? What if I'm falling back to a different LLM? That might not have the that might not process the prompt in the same way. So of course there is a little bit of exploration there, and we also want to log any errors that's handled, right? Now this goes into production, and weekly or monthly you want to monitor the kind of errors that the users have faced. You want to keep track of them, maybe log these errors, identify areas where the models were failing, and improvise on them. Sure, the model can run once properly, but the next time you run, maybe it didn't capture the details and it just broke in between. You want to keep a track of all this, right? Finally, moving towards the SQL query. Now we want to make sure these are accurate, right? And okay, it's not just here. I think this is something that we should have brought in earlier, but in these stages we had obvious concerns in between, so we're trying to optimize them. But now that we have built sort of a baseline end to end, and in future when we are going to modify each of these nodes and modules, irrespective of what we change, right, we want to stick to, or we want to ensure that the model, irrespective of the changes that's happening within itself, should be able to generate accurate answers for the given user question. So we want to build a set of test questions along with ground truth answers, and validate um, the model's performance every time we optimize it. So maybe we can have a 5 to 6 simple user questions, some complex ones, some involving multiple joins, or maybe some involving multiple filters, and maybe manually write answers for each of them. And then you can use a tool like langsmith that integrates well within the langchain or langgraph framework to test these to test the model's performance when anything in the model changes. So that's one. And the second would be to simply validate the output, right? And this is not in terms of validating its validating the answer, but in terms of just validating its the quality of the answer, right? And what I mean by that is, maybe you don't want the model to use certain aliases, right? Let's say you have transactions table, and maybe it's an internal thing within your business that you want to always alias it to txn transaction, right? So you want to use certain aliases, or maybe you want it to always use a left join instead of a right join, right? Maybe you want to always put in your the final answer within a CTE, so as to say. So you want to make sure that the final SQL query is free from any common mistakes, or you know is in the way that you want. Now, sure, this is something that you can pass on in this step. You can pass it on as additional instruction saying, hey, do this, do this. And I'm sure we also specified certain rules within here. But like we saw earlier, this also has a lot of to do in within itself, right? It takes in a bunch of questions, and it is already doing a lot of steps here. So you don't want to burden it with certain additional restrictions. So what we can do is add an additional node here that simply does only validation. So that way, when something goes wrong, we can say, hey, this is the node that is going wrong, and we can try and optimize that. So that would be the validation step. And there's also a couple of things that we can broadly cover. One is human in the loop feedback. Of course, the one area where we can implement is here. The user, the sort of model LLM can go back to the user requesting for additional information. We can also implement it here towards the end. Let's say after the SQL generation, we have connected it to the SQL database. Now this human in the loop can be added here. The model can or the LLM can, maybe if it identifies that this code can be or no, ignore that. It can just take in the user's feedback. It can show the SQL query and take its approval before actually querying the database, right? So that way the user can have a quick look and ensure it's safe to run it, and then it can go and run the database or query the database with the human's involvement. Right, we can also involve the humans involvement in terms of the quality of the query provided. Sure, query is provided, but the human also can input some feedback, and that can be logged separately just from engineering point, that if the users are not satisfied with the output, we can go and optimize it or find out why they don't, why aren't they happy with it, and so on, right? So that's the human in the loop aspect. And finally is like an agentic aspect, AI agent. So, see, the AI agent and agentic workflow are two different things, and they can be blurry in terms of definition, right? The workflow we built is an AI workflow. um, AI because of course it involves all the LLMs and the AI aspect, and workflow because it's sort of like an end to end. It goes from A to Z or A to B, whatever, right? But maybe we should also try and include an AI agent. And AI agent is when it decides on its own which path to take, right? Now here I mentioned, I'll come back to this later. Now, what if the user is simply querying the same question, right? Maybe there is one analyst who's querying for the top 5 customers in this department. There's another analyst in the team who also wants to know this information. Now, you don't necessarily want to go through all the steps just to generate an answer that was simply queried or requested a few minutes ago or sometime in the past, right? Maybe you want to create a database that involves all the questions and the SQL generated variants. So if the question was previously asked and is stored in the database, the AI agent can simply go and access it and pass it on to the user. If not, it can decide to take this traditional step, or maybe it feels that, hey, I have a partial answer here and maybe I need some more answer from the user, and it can decide to take in the human in the loop aspect. So here we have brought in three different path, and there is no defined path here, right? The LLM or the AI agent decides which path to take, and this is something called as the AI agent. This can we can also try and bring an agent in the end, where it can decide whether it needs more context from the user, or if it can run the database, and so on. So that is something we can explore. So yeah, I think I broadly covered all the areas that has scope for improvement. So like I mentioned, in a real world setup, all of this depends on the business context and the specific use case. Now, maybe you're just dealing with a small database, right? You can ignore this entire step here of table generation, or let's say sub question generation. You can directly feed in the specific data, the tables, and you can generate SQL question. Or maybe you want to pass on through all the steps, but maybe it's a smaller knowledge base, and you're okay with passing the entire knowledge base instead of building a RAG system upon here. You can ignore that step. Error handling and logging, guardrails, validating output are something that's important irrespective of the business use case. But certain other aspects have some dependency. But of course, like I mentioned, this is analytics project, right? Where we're like, trying to explore the various aspects. So it's a good sort of learning curve for us to explore each of them. I'm not sure which I'm going to do next. I think I'll probably start with building the test questions and ground truth datasets. So that way, when we move ahead with building the other components, we'll know that none of this ends up breaking the model, and we can be sure that irrespective of the changes that we make elsewhere, we get the absolute perfect answer in the end. And as to say, even this model may not be efficient. I might have to go back and improvise certain prompts, because we didn't necessarily focus on validating the quality of the SQL query. I think even in the demos I only showed 1 or 2 questions, and personally I only tested with a handful of questions. So that is obviously one area where I should focus on next. But yeah, that's it for the video. Thanks for watching, and thanks for all the engagement in the previous videos. If there are specific questions or suggestions that you have for me, I'm happy to take and incorporate it into my further videos. Until then, see you.